Now let's look at the trapezoid rule. Sometimes we have functions that don't have explicit antiderivatives, and when that happens, you cannot find the exact area under the curve. But there are several methods of approximating it, one of which is the trapezoid rule. Well, the first thing you do, and this should all look familiar, is you find delta x, and that is going to be your b minus a divided by the number of trapezoids you want to use. So in this case, n is 4 because we're asking you to approximate it using 4 trapezoids. So you're going to find delta x is b minus a divided by n, which is b minus a divided by 4. And you're going to divide this. You'll usually have a number line. Usually I start with half, and you go up to this point right here, and you mark it on your curve. And then you cut that one in half. And then you cut this section right here in half. And then you sketch the trapezoids. So you start at f of x evaluated at a, and you connect the dots. Now, as you do this, you see I'm constructing 4 trapezoids, some of which are over, some of which are under, some of which are fairly close. But this will be a good enough approximation if my delta x is small enough. Now you remember the area of a trapezoid is 1/2 base times height 1 plus height 2. Now in this case, the base is delta x. So whatever your delta x is your base. Now what are your heights? Well, your heights, say I'm looking at this one right here, the area of this trapezoid right here. The height is my functional values, my 2 functional values. So for this one, it would be f at x1 plus f evaluated at x2. In general, you're going to want to make a chart because I think that makes it easy. In general, you also usually have a calculator with these. So if we look at the area of the first trapezoid, what is that going to be? Well, it's f at x0 plus f at x1 divided by 2 times delta x, which is b minus a over n. Now, if you extend this to the ith trapezoid, you get a function of f of x sub I minus 1 plus f of x sub I over 2 times b minus a over n, where this is your delta x, and this is 1/2 of h1 plus h2. So I guess this is your base. Now, the trapezoid rule says as long as f is continuous, you can approximate the area. Now, look at how it winds up stretching out. You wind up with b minus a over 2n. So here's your half. Here's your delta x. Now you have 1f evaluated at x0, 2f evaluated at x1, 2f evaluated at x2, and so on until you have 2f evaluated at xn minus 1, but then only 1f evaluated at xn, or at b. And clearly, as n goes to infinity, this approaches the definite integral. Now, let's use the trapezoid rule to approximate the integral from 0 to pi of sine of x dx. Well, let's just do it breaking it into 4 different trapezoids instead of trying to use a formula. Let's call this area 1, 2, 3, and 4. So what is the area of the first trapezoid? Well, it's 1/2. Oh, I need to find my base, don't I? My delta x in this case is b minus a over n. N is 4. B is pi. Pi minus 0 over 4. So it's pi over 4. So this is 1/2. The base is pi over 4. Now, this is a degenerate trapezoid. It's actually a triangle because my function evaluated at 0, sine of 0 is just 0, plus sine of pi over 4. So what does this become? This becomes pi over 8. Sine of 0 is 0. Sine of pi over 4 is the square root of 2 over 2. So this is 2 square root of 2 pi over 16. Now let's look at A2. A2 is 1/2. My base is still pi over 4 times the sine of pi over 4 plus the sine of pi over 2. So this is pi over 8, sine of pi over 4, square root of 2 over 2, and the sine of pi over 2 is 1. And I'm going to leave it like this. A3 is 1/2 times pi over 4, because that's my base, times sine of pi over 2 plus sine of 3 pi over 4. So this is pi over 8 times the sine of pi over 2 is 1 plus square root of 2 over 2. And the fourth area is 1/2. The base is pi over 4. Now sine of 3 pi over 4 plus the sine of pi gives me pi over 8 times the square root of 2 over 2, or pi square root of 2 over 16. So the total area, I add all of these up. The actual area is approximately equal to square root of 2 pi over 16 plus pi over 8 times the square root of 2 over 2 plus 1. And I actually have two of these, don't I? So I'm going to put times 2 out here. And then, oh, I have another one of these, so I'm going to put plus 2. So if I put this in my calculator, this is 1.974 approximately.